Hello! In this video we'll be talking about section 2.2, Systems of Linear Equations with 3 Variables. So let's look at this. I have 2x minus 3y plus z equals 1. I will label that as equation number 1. X plus 2y plus z equals negative 1. I'll call that equation 2. And 3x minus y plus 3z equals 4. I'll call that equation 3. My goal here is first to take two of these equations, eliminate one variable, another two equations, and eliminate the same variable. I'm going to say, for example, let's do eliminate z. I'm going to do so because I look at equations 1 and 2. Those both include an individual z, which means all I would need to do is subtract them to get that eliminated. So what I'm going to do over here, I will take equation 1, and I will be subtracting equation 2. So that's going to be 2x minus 3y plus z equals 1. And then I'm going to subtract the equation x plus 2y plus z equals negative 1. 2x minus x will give me just a single x. Negative 3y minus 2y will give me negative 5y. And then the z minus z will cancel to just give us our constant term on the right. 1 minus negative 1 is 1 plus 1, or 2. I'm going to call this new equation equation 4. Now I'm going to take another pair of the original equations and eliminate z in order to find a new equation. I already did equations 1 and 2, so let's say, for example, I'll do equations 2 and 3. You can do whatever pair you want, but I'm choosing to do this one. In order to do that, however, I'm not just going to be able to add or subtract these equations like I did for the first two in order to eliminate that variable z. Instead, I am going to need to multiply one of those by another constant and then add or subtract them. Because I have a 3z in that third equation, I'm going to take that second one and I'm going to multiply that whole thing by negative 3. If I do that, I will then be able to take equation 3 and then add my new equation of 2, which will be negative 3 times 2. In order to get that new equation, however, I'm going to do that on the right side first. So I'm going to take that second equation, x plus 2y plus z equals negative 1, and I'm going to multiply that by negative 3. Negative 3 times x will give me negative 3x. Negative 3 times 2y will give me negative 6y. Negative 3 times z will give me negative 3z. And negative 3 times negative 1 will give me a positive 3. Now I can take equation 3, the original 3x minus y plus 3z equal to 4, and I can add that with this new equation that we have, or at least the new variation of equation 2. That would be this negative 3x minus 6y minus 3z equals 3. If I combine those together, 3x and minus 3x actually will cancel out as well and just nullify. Negative y and minus 6y together will take a total of negative 7y. 3z and minus 3z will also eliminate, and then on the right side I get 4 plus 3 will give me a total of 7. This is technically equation 5 now, but you'll notice that there's only one variable in this equation. This is awesome because now all I need to do to get y by itself is divide that second equation by negative 7, and now I have one of my variables solved. If I go ahead and do that, if I divide that by negative 7, I'll get y equal to 7 over negative 7 is negative 1. It still was necessary to get another equation like we had with equation 4 though, because now I can take that solution for y equals negative 1 and I'll plug that into equation 4. So I'm going to take that equation number 4 again, this one here, x minus 5y equals 2, and I'm going to plug in negative 1 in place of y. If I do, that will give me x plus 5 equals 2. And then I can solve for x by subtracting 5 and get x equals negative 3. Now with these two solved, I can then plug that into any of the original equations and solve for z. I'm going to elect to do equation 2 because that looks the simplest, only has a single instance of both x and z. It's really up to you though in terms of what you choose. So I'm going to take equation 2 there, x plus 2y plus z equals negative 1. I'll plug in negative 3 for x, then negative 3 plus 2y, z I'm going to plug in negative 3 for x, and then negative 1 for y, plus z will give me negative 1, and all I need to do there is to get z by itself. I'll first combine terms on the left side. I get negative 3 minus 2 plus z equals negative 1. Negative 3 and negative 2 create negative 5 plus z equals negative 1. And then if I add 5 on both sides, I get z equal to negative 1 plus 5 is 4. I now have my solution, which I can write as an ordered triple. X is negative 3, y is negative 1, and z is 4. Remember from here, if you would like to do any other checks, you can then take this ordered triple and plug that into the 3 equations we had originally and make sure all of them create true statements. I'll let you do that if you so choose. Have a nice day.